a lot of questions on factorial which go something like this. Find the highest power of a given number that divides a factorial. It will be given which factorial and so on. Or what least number when multiplied with a factorial will result in a perfect square or a cube. It could be multiplied, it could also be divided. Or with what least number should n factorial be divided such that the quotient is not a multiple of a certain number. All these language should be very familiar to you from the lesson on factorization. In that lesson, using the factorized form, we could make out if the number is a multiple of 2 or 3, or what's the highest power of 6, 12 that divides a given factorized form. Whether a factorized form, looking at the factorized form, we can infer whether the number is a perfect square or a perfect cube, right? So the lesson on factorization is a prerequisite to this part that we are going to do. I have explained a lot of these types over there, so I'll save time here by not doing in its entire details. All that we need to learn in this part is how do I factorize a factorial. And once I factorize a factorial, I'm left with the factorized form, right? What is that factorized form? Let me again remind you. Factorized form in its general sense is a prime number raised to a, another prime raised to b, another prime raised to c, and so on, right? Where p1, p2, p3 are all distinct primes. For simplicity, we just simply take this as 2 raised to a, 3 raised to b, 5 raised to c, 7 raised to d, and so on, right? So we will learn how do I factorize a factorial. Once I've arrived at this stage, then all these questions we have covered in that lesson. So if you have not done that, first do that lesson and then come back and continue here. Let's learn factorizing a factorial with the example of 15 factorial. So by factorizing we mean write 15 factorial as in its factorized form 2 raised to what into 3 raised to what, 5, 7, 11, 13, 17, 19, these are all prime, the atoms of numbers, and how many 3's are present in a 15 factorial, how many 5's need to be multiplied to result in a 15 factorial, and so on, right? 15 factorial, from a basic understanding of factorials, we know is the product of first 15 natural numbers that I've written on the board. Now, the task that remains is this 8 is not just a number 8, it is made up of 2 into 2 into 2. So it's going to contribute 2 to the power 3. 9 is going to contribute 3 to the power 2. Right? 10 is going to contribute a 2 and a 5. 2 into 5, right? So what remains is these individual numbers, I need to break them into the primes, right? So just by looking at some of this, I can see that at least the higher powers are very obvious. There is no 19. Is there anywhere a 19 that will be present? Remember, 19 is a prime number. It cannot be formed by any others here, right? There's no, even a 17 is not present, right? So some of them are pretty easy, the larger primes as such. 13, oh, I see a 13 here. Will there be any other 13 here? 13 is a prime. No numbers can combine and form a 13. So that's just going to be 13 raised to 1. Right? How about 11? 11 is also present as a prime, and there cannot be any other way that 11 can be formed. So that is going to be 11 raised to 1. Watch out for 7. You might say, is that logic correct by saying 7 is present 1 and there can't be any more 7's from by any two atoms combining? Yes, there can't be, but is that just a single 7? Is there not 7 into 2, 14, 7 present here as well, right? So watch out. As we come lower down, there will be plenty of such atoms, right? For example, why can't we just do this orally here? If I look at 2's, there will be a lot of 2's. 2, 2 into 2, 2 into 3, 2 into 2 into 2, 2 into 5. Here there's a 2 into 2 into 4, right? So with smaller atoms, there are going to be many 2's, many 3's. Will you just use colloquial usage? Yeah, many 2's, many 3's, and so on. Understanding that it's a product of all of them. How do we find those numbers then? Can we get a method to do it rather than just count in a arbitrary manner? So I'll take a little time. I'll draw each of these numbers into its prime, I'll break them into its prime numbers, prime factors, and then continue. Meantime, you also could pause it, try to break them into prime numbers, prime factors, and see whether you can get a counting process on your own. You should be able to, it's not all that difficult.